This question asks you to find the probability of graphs of randomly generated quadratic functions having a specific number of x-intercepts. In parts from a to f, consider quadratic functions f of x is ax squared plus bx plus c, whose coefficients a, b, and c are randomly generated in turn by rolling an unbiased six-sided die 3 times and reading off the value shown on the uppermost face of the die. For example, rolling a 2, 3, and 5 in turn generates a quadratic function f of x is 2x squared plus 3x plus 5. Question A. Explain why there are 216 possible quadratic functions that can be generated using this method, 1 mark. So, quadratic function is a x squared plus bx plus c, and since it's a six-sided die and is unbiased, so definitely possible values for a, b, and c are from 1 to 6, and they can be repeated, so there are 6 variants to choose or to get the value of a, so 6. And since it's and at the same time to get the values of a, b, and c, so it's multiplication. 6 variants to get a, the value of a. Also, there will be 6 variants to get the value of b, and also there are 6 variants to get the value of c. And together, it's what? It's 216 variants as required. Question B. The set of coefficients a is 1, b is 4, and c is 4 is randomly generated to form the quadratic function f of x is x squared plus 4x plus 4. Verify that this graph of f has only one x-intercept, 2 marks. You may consider what? A discriminant, and to show that discriminant is equal to 0, and you know if discriminant is equal to 0, it implies what? Only one root, or it means 2 equal roots, or it means what? Only 1 point of x-intercept. So discriminant is b squared, it's 16 minus 4ac is 0. Hence f of x has only one x-intercept. Or we can show that it's what? A complete square. It's clear using the formula a plus b squared. It's what? A squared plus 2ab plus b squared. It's x plus 2 squared. And equating it to 0, we can see that x is negative 2. It's the only x-intercept. The next, C. By considering the discriminant or otherwise, shows that the probability of the graph of such a randomly generated quadratic function having only one x-intercept is 5 over 216, 6 marks. Definitely probability is what? It's number of favorable outcomes, or the outcomes we need, divided by total number of outcomes, and total number definitely it's total number of possible values of ABC to be generated is 216, and it's actually a hint that there must be what? 5 variants so that there is only one x-intercept, and it is given that we should use discriminant, and function in general it's what? It's a x squared plus bx plus c, and discriminant it's what? Is b squared minus 4ac, and it must be equal to what? To 0. You may consider b squared to be equal to 4ac, and a, b in c, or a, b in C. Possible values, it's what, 1, 2, 3, 4, 5, 6, because they are generated from what? From an unbiased six-sided die. And let's consider all possible combinations to get this to be equal to 0. And let's start with what? With A to be 1. If A is 1 and when C is 1, you can see that B is 2, or when B is 2, you can see it's one possible variant, so that it is equal to 0. And notice that A, B, C are integers, and these values only. And you need to consider all possible outcomes. And we start with A to be 1, and let's continue. If A is 1, what not? And actually, since all values are integers, when C is 2, you get what? 8, but it cannot be that integer squared to be equal to 8, so C cannot be 2, so 3, it's what? It's 12, so definitely B squared cannot be 12. Or actually you may consider B to be equal to root of AC to be more clear, and it becomes 2 root of AC, and definitely what? AC must be such an integer so that the square root exists. So when C is 3, when C is 4, you get what? 4 times 4, 16. Yeah, B is 4. And notice that there will be another possibility, since it's a product, 4 and 1. But let's consider with A. So when A is, and if you check when C is 5, it's what? 20, and when C is what? 6, it's 24, and B square root doesn't exist, so no variance. And when A is 2, and when C is definitely 2, it's 4 times 4, 16. B is, again, it's 4. And you may check that all other variants give that square root doesn't exist. And when A is 3, C is also 3, so it becomes 9 times 4, or 36, and B is 6. And this variant, but when A is 4 and C is 1, because two possibilities to get AC to be equal to 4, and B is 4 again. And you can see that there are 5 possibilities in total. Or we can say that probability, or you may say that there are 5 favorable combinations or outcomes, and there are 260 combinations in total, hence the required probability is 5 over 216, or probability of each combination is 1 over 6 times 1 over 6 times 1 over 6, it's 1 over 216. And there are 5 possible combinations ABC, hence the required probability is 5 over 216. The next. Now consider randomly generated quadratic functions whose corresponding graphs have 2 distinct X-intercepts. What does it mean? It means the discriminant must be greater than 0. D. By considering the discriminant, determine the set of possible values of AC, 3 marks. So discriminant is what? B squared minus 4AC, and it must be greater than 0. So 4AC is less than B squared. But since B can be from what? From 1 to 6, the greatest possible value of B is what? Is 6, so B squared is 36, so for AC or just AC and maximum possible value is less than 36 over 4, so AC maximum is what? Less than 9, strictly less than 9, but the minimum value of AC, it's what? It's 1, because A mean is 1, and B, not B, the minimum value of C, it's also 1. Hence, a product of AC can be greater or equal than 1 and less than 9. Or, since it's about integers, product AC for AC, it can be what? 1, 2, 3, 4, 5, 6, 7, and 8. The next, EI. For the case where AC is 1, shows that there are 4 quadratic functions whose corresponding graphs have 2 distinct X-intercepts, 1 mark. So when AC is 1, definitely there is only one variant. It's 1, A to be 1 and C also to be 1. And since we need 2 distinct roots, there must be what? Discriminant, which is what? B squared minus 4AC must be greater than 0, or B squared must be greater than 4AC. And since AC is 1, so B squared must be greater than 4, and B as it's any number what? From 1 to 6. And when B is what? 1 squared not greater than 4, 2 squared also not greater 3, its possible value, because 3 squared 9 is 4, 3, 4, 5, and 6. And since there is only 1 mark, we can show like this. And what actually, for the case, I repeat the question, for the case where AC is 1, shows that there are 4 quadratic functions. Yes, and hence there are 4 quadratic functions. I hope it's clear that one function is when A is 1, B is 3, C is 1, another is 1, 4, 1, 1, 5, 1, 1, 6, 1. The next, for the case where AC is 2, shows that there are 8 quadratic functions whose corresponding graphs have 2 distinct X-intercepts, 2 marks. And first of all, to get AC to be 2, A may be what? 1, C can be 2, and also it can be another combinations 2 and 1, so 2 and 1. And the same condition, discriminant to be greater than 0, b squared to be greater than 4ac. So b squared is greater than what? 4 times 2 greater than 8. So possible value for b are what? It's 3, 4, 5, and 6. So b 3, 4, 5, and 6. And so we can see that there are 8 combinations and hence 8 quadratic functions. The next, let P be the probability of the graph of such a randomly generated quadratic function having two distinct x-intercepts f. Using the approach started in part E, or otherwise find the value of P. 6 marks. So what does it mean? You can see that to have two distinct roots, possible values of AC are from 1 to 8, and we have considered 1 and 2, and you should consider all other values from 3 up to 8 and do absolutely the same and find the total number of possible combinations and then dividing by 216 the grand total of possible all possible combinations of A, B, and C, and hence we get the required probability. So let's continue. When AC is 3, possible combinations of A and C to get 3, it's what? A to be 1, C to be 3, and also it may be A to be 3, C to be what? 1. And the same condition, B squared to be greater than 4ac, so b squared is greater than what? 4 times 3, 12, and definitely possible values for b, it's what? It's from 4, 5, 6, 4, 5, 6, because 4 squared 16, definitely 5 squared and 6 squared will be greater than 12. And you can see 3 and 3, 6 quadratic functions. Then when AC is 4, possibilities A to be 1, C to be 4, A to be 4, C to be 1, and also A to be 2, C to be 2, and for B, B squared is greater than 4AC, so B squared is greater than what? 4 times 4, 16, so B is 5 or 6, 5 or 6, 5 or 6. So 2, 2, 2, and so 6 functions in total. 6 quadratic functions. When AC is 5, so A is 1, C is 5, and definitely there will be only 5 and 1 because it's a prime number, so it's 1, 5, 5, 1. And again, B squared greater than 4AC, B squared is greater than what? 20, so it's again 5 and 6. And 2 and 2, 4 quadratic functions. Then AC is 6, so it may be A is 1, C is 6, A is 6, C is 1, and 2 and 3. So A is 2, C is 3, A is 3, C is 2. And B squared is greater than 4AC, B squared is greater than what 24, it's again B is 5 or 6, and what 8 quadratic functions, and AC to be 7. Possible combinations with respect to integers, it's what 1 and 7, but values for ABC are what from 1 to 6, and 7 is a prime number, so there are no combinations for A and C to get 7, so no quadratic functions. And AC to be 8, the final possible value. It's what 2 and 4, and 4 and 2, and that's all. And again, what B squared is greater than 4AC, so B squared is greater than 32, and it's only 6. And 2 quadratic functions. And now the required probability is the total number of possible quadratic functions divided by the required or the favorable quadratic functions divided by the total number of all possible quadratic functions. It's 216, and you should just add up all quadratic functions from AC to be 1 up to AC to be 8, and it is equal to 4 plus 8 plus 6 plus 6 plus 4 plus 8 plus 0 plus 2, and it's 38 over 216. 1, 2, 3, 4, 5, 6, 7, 8. And it's the required value of P. The next part. In parts G and H, consider a randomly generated quadratic function f of x to be x squared plus 2zx plus 1, where the continuous random variable z is distributed normally with parameters 0, 1. It's a standardized normal distribution. G. Find the probability that the graph of f has 2 X-intercepts, 3 marks. And again, to have 2 X-intercepts, there must be what discriminant, which is what B squared minus 4AC must be greater than 0, and here it becomes what, and actually B squared must be greater than 4AC, and B squared, B is what, it's 2z, so 4z squared must be greater than 4 AC, A1, C1, so greater than 4, so z squared must be greater than 1. And squared to be greater than 1, it means that we need probability that z is greater than 1 or z is less than negative 1 under z is distributed normally with parameters 0, 1. And just using a calculator, and you remember that this normal distribution is symmetrical about 0, so greater than 1 or less than negative 1, it will be symmetrical. So it's enough what to find, for example, less than negative 1 and just multiply by 2. And actually let's write this, that it becomes 2 multiplied by probability of z to be less than negative 1. And you remember that here actually for this we should write strictly less or less or greater, but you remember that for normal it doesn't matter this less or less or equal, because at a point, due to normal, probability at a point is equal to 0. So we need just usual normal, so normal CDF. Lower, definitely as it's from negative infinity, but you remember you can enter, for example, negative 100. In general, it doesn't matter because it decreases very rapidly or tends to 0 very rapidly. And upper, we need negative 1, under 0, 1. And actually it's required, and multiply by 2, and it becomes 0.317 to 3 significant figures. The next, and actually the last question H. The continuous random variables x1 and x2 represent the x-intercepts of the graph of f, where x1 is negative z minus root of z squared minus 1, and z2 is negative z plus square root of z squared minus 1. And you may notice it's about what? These x1 and z2 are just roots, using our usual formula for roots. What formula? Minus b minus root d over 2a, and negative b plus root d over 2a. So x1 and x2 just the roots of these quadratic function. And question H, actually given that the graph of f has two x-intercepts, x1 and x2, find the probability that both x1 and x2 are greater than 0.5. First of all, if you meet given, it indicates what? That there will be what? Conditional probability, be aware. And again, given has two x-intercepts, find the probability that both x1 and x2 are greater than 0.5. So it's what? It's concave up parabola. First of all, it's concave up parabola, and there are two roots. One is negative z minus root, and another is negative z plus root. It's smaller, so to the left, and both to be greater than 0.5. It's required that the smaller root, which is negative z minus square root, to be must be what? Greater than 0.5. Because the second root, which is greater, will be automatically greater than 0.5, because parabola, concave up parabola, looks like this. So the situation looks like this, and together with together with and actually it's a domain of this quadratic square root. But since it is given that definitely two roots, there are two roots, so discriminant, and it's actually square root of discriminant, so this z squared minus 1 is greater than what? 0, or it's the same as we use this given, this actually. It's this probability is 0. So and you may also notice that you can see negative z minus square root. Square root gives us what? Always positive value. So minus something minus positive, and if z is positive, there will be minus, and it's impossible to get greater than 0.5, and hence z is negative. Definitely when z is negative, there will be minus negative, so some positive minus positive, and it's possible to get and definitely we can find a critical point, just equate and solve for to be 0.5, but to avoid mistakes, let's solve it using a calculator. What to solve what? This to be greater than 0.5, but provided that, so it becomes what? Negative z minus root z squared minus 1 is greater than 0.5, and together with z is less, here it's also can be equal to 0, so it just these two exist, is less or equal than -1, or z is greater or equal than 1, but z is greater than 0. Actually, for it's we can conclude it from this, so z is negative, and hence from this part there will be no solutions. It's not required to emphasize that z is less than 0. It's because you can see that we need what? Simultaneous. It must be true what? Simultaneously, but since z is negative, there will be no solutions with this part when z is greater than 0. So it's enough to consider actually only this, negative z minus root z squared minus 1 to be greater than 0.5, together with z is less or equal than -1. So we will consider just from -1 and to the left, and we consider this function together with 0.5. 0.5, it's from -1, this point included, and actually this point and solution will be where, or actually it may be not like this. You don't need this. Let's use a calculator. Ignore this sketch. So we need to solve this actually. And how to do that? Oh, my sketch is not correct because it's minus, so it will be reflected a root. So my sketch is not correct actually. So we need this negative x minus root, and another function is 0.5, and window let x be from -5 up to -1, and y, for example, from -1 to 2, because there will be y is 0.5, so definitely we don't need very large value for y. And let's see. Oh, you can see that it's correct graph of this root because it's minus, so it's reflected. And you can see that point of intersection is this, and the left hand side is this curve to be greater than 0.5. so you can see solution is greater than this point of intersection up to -1, because they must be true together. It's intersection, it's like and. So we need point of intersection, and calc, oh no, we need calc intersection. First curve, yes, it's this one. The second curve, yes, this one. Guess is this one. So this point is negative 1.25. And what? The solution of the first is x is greater than negative 1.25, because curve is greater than 0.5, it's to the right. But also z must be less or equal than 1. So together the solution is z is greater than negative, not it's strictly greater than negative 1.25 and less or equal than negative 1. I repeat that we don't consider this part, because from this we can conclude that z must be negative, so there are no solutions for z is positive. And I repeat, we consider simultaneously two inequalities. One inequality is directly what is required, another it's actually domain of this function, and it's also from given, because the next step it will be what? The required probability. I repeat that given that graph has two x-intercepts, and you remember that formula for the conditional probability is probability of what? And what we need, and this given, so we need probability that two roots, there are two distinct roots, and this condition is actually this, and at the same time both x1 and x2 must be greater than 0.5, and the numerator, it's actually the solution of our system of two inequalities. So the numerator becomes z is greater than negative 1.25 and less or equal than negative 1. At the same time, and since it's given, its conditional probability, according to the formula for conditional probability, must be divided by the probability of given, and probability of given that there are two x-intercepts, and this condition that z squared z squared minus 1 is greater or equal than 0, or z is less or equal than negative 1, or z is greater or equal than 1. It's actually this answer for the previous, this. But let's use the exact values, so it becomes 0.3173, and so on. And now we need just what this, again normal CDF, lower, now it's negative 1.25, upper is negative 1. Yes, and it's 0.0530 and so on. And divided by 3.3173 and so on, it's enough to 4, because finally we need to 3 significant, and you can see that we get that it is equal to 0.167 to 3 significant figures. And that's all for this question.